yeah, Space Weather Sunday Night Edition, and things are moving up once again. We'll be talking about things like solar cycles and lots more tonight here at the Smash News Network, least busted name in news, and congratulations on realizing that the channel exists. I'm your host, Dan, a.k.a. Smash-O-Mash, just bringing you the world's most comprehensive daily space weather show, along with the most detailed solar imagery you'll find in the known universe. We don't kick it up a notch. We're the notch at which it is kicked up to. You wish you could kick it up to this notch. Other space weather channels. Shout out to Tamitha Scove, a real space weather channel. And before we get to more solar imagery from SDO, and we've got a lot, here are the HMI images briefly. There's the continuum, and we do have at least one new sunspot just rose in the east. It's a new flare player, so we'll have flare likelihood both in the northeast and along the western limb. Let's take a brief look at what's going on with volcanoes. These are the erupting issues Sakurajima. Let's don't forget Subanose-jima Ibu. Looks like some intense activity happening there. Luatobi, Popocatépetl, Santiaguido Fuego, Nevado de Ruiz, Sangay, Revenador, and Sabancaya. Next, earthquakes, and another interesting earthquake has happened in the past 24 hours. It was a 6.5 at Brazil. We'll tell you all about it. And man, oh man, once again, in the middle of nowhere, but a little bit more, a little bit more populated than last time, as I do see signs of life there. So, but keep in mind that 6.5 magnitude quake was at over 600 kilometers estimated depth. Way out in Brazil, out toward the Peruvian border. That's the satellite image. Let's switch to the topographic map to show what's around the area. Yeah, that was a 6.5 magnitude quake at 609 kilometers. Very deep quake there at Brazil. Also a lot of quakes in the Americas. Check it out. The Eastern Pacific Rim, a whole series of quakes all the way into the Caribbean up to Alaska. So yeah, quake risk here. Have we seen foreshocks happen in California? Let us know in the comments what you think. And by the way, thanks for tuning into the Smash News Network, least busted name in news. 2 other channels that cover space weather. Please don't shartlight. It's just sad. Here are the quakes of a 5 and greater magnitude over the past 24 hours. And not many, but quite a few here in the 4 range. So first on the list is that 6.5 at Brazil at 9:38 this morning. 609 kilometers estimated depth. Taiwan had a 5.1 at 11:22. I'm sorry, at 18:11. Yeah, 1811. Looks like it was in a populated area too there, as it looks like it caused some damage. Not too far from Guangfu. Anyway, there's the map of that. And that's it. Only 2 5 or greater magnitude quakes, but a lot of quakes around the western coast of the Americas. Anyway, like I said, here's some more solar imagery for you. There's another 24-hour video from SDO. That's the 304 plus 193 angstroms. Splentacular at showing filaments. And let's get to some space weather stats. The 10.7 centimeter radio flux is at, I don't know, somewhere. There's the 1-year graph. And we're going to come back to Solon.info to talk about solar cycles here in a brief moment. First, there you go, sunspot. Radio flux, is at 141. 141 is the current F107, the 10.7 centimeter radio flux. And if you look at the red line and the black line, you can see how correlated they are. They are directly proportional to each other. Radio flux and sunspot number. They are the 2 most accurate reflections of where we are in the solar cycle, which, again, we'll get back to here in a moment. So no space weather storms. Oh, check it out. There actually is a little bit of activity there. I believe that's from a coronal hole high-speed stream, if I had to guess, which I don't. But some geomagnetic unrest forecasted by NOAA there on the evening of January 30th. So that's a coronal hole high-speed stream, I suspect, as we haven't seen any new CME's headed this way. So that narrows it down by process of deduction. Coronal hole stream likely, according to NOAA, January 30th. Here are the past 4 hours of Earth's magnetic moment from space. And remember, folks, on dreary days, wear bright colors. Nothing says don't run me over or shoot me like blaze orange. Today, of course, wearing the pink flamingo shirt. If you like your own, head to amazon.com/shop/smashomash. Check out the spacewear collection. That's what to wear on a gloomy day. And, let's let that play through. Get the full 4-hour cut there. So, yes, Earth's magnetic moment from space. That's what a proton experiences when it shows up from the solar wind. That is a result of Earth's magnetosphere that's depicting magnetohydrodynamic pressure. And yeah, there it is, the space weather modeling framework. Earth's magnetic moment from the ground, and we do have a little bit of activity here. So likelihood of aurora here much higher than it's been. I think we're at KP3 actually right now, so a little bit of action coming through here, but no major solar wind activity. Just a little bit of an uptick in things like density and I think magnetic field strength. We'll get to it in a moment. So, but that's what's going on. Maybe magnetic field orientation. Yeah, KP3 is the current situation. There you go. KP3 is the state of global geomagnetism. And pardon my head being partially transparent. I've got space on the brain. Next, how about some real-time solar wind data? First, the ACE, which has like 6 hours of missing data. Let's skip it and go to the Discover. Solar wind density here about 8.5 protons per cubic centimeter. Solar wind velocity here elevated. Oh, this already looks like a coronal hole high-speed stream. Check it out. It made it all the way up to about 18.5 protons per cubic centimeter. When it dropped off, the solar wind speed came up. It's a coronal hole high-speed stream already arriving, folks. So here comes the high-speed portion of it, and the magnetic fields are not looking super conducive to geomagnetic activity. Sorry, aurora chasers. It's not looking like a major impact. But elevated solar wind there at 457 kilometers per second for the velocity, and you can see also this telltale sign right here. This green line right here, the plasma temperature, usually a steady signal there when you see a coronal hole high-speed stream, so it's very indicative of that. GOES magnetometers here are pretty chill. Pretty chill. Shout out to Mark Rebillet. Mark Rebillet, folks. Mark with a C. If you haven't seen the channel, check it out. It's absolutely splentacular. As Mark has created a new genre unto himself. Anyway, here's our top view plane field plot. And Mark is actually playing at 6 p.m. tonight on Sunday night, by the way. So he's starting his show in 15 minutes in Venice Beach, California, by the way. Check out the live stream on YouTube. So, yeah, Earth is still in a South Pole current sheet, a South Pole heliospheric magnetic sector, but just barely. So we thought we'd be in a North Pole sector by this point tomorrow. Not quite yet. It'll be here within about 6 hours, most likely. So, sector boundary crossing coming before tomorrow's daily space weather video. Here's our line of sight coronal hole, our line of sight field plot, rather. It shows all of the magnetism, right? And we're going to talk a little bit later about the differences between the photosphere magnetism and the polar fields, right? You can see both here. The grayscale depicts the photosphere magnetism, and the blue portion is the solar B field, which is sort of like the net field of the solar atmosphere, known as the corona. And then you've got the polar fields themselves. Those are the inputs to the B field. The red and green lines represent the potential field surface source lines of the polar fields. North is green, south is red. And anyway, let's move on to coronal holes. I don't want to get into a whole complicated explanation of that. After all, it is the daily space weather. Here's our line of sight coronal hole plot. And we've got North Pole coronal holes rotating in, as you'd expect, with a North Pole heliospheric magnetic sector showing up. So that's what's going on. And let's get to coronal holes from SDO. So there you go. There's our 211 angstroms wavelength. And if I had to guess, I'd say we're getting some early coronal hole high-speed streams from one of those two coronal holes. I would say probably more likely this one, just based on Earth's location, and of course that one is further advanced approaching the western limb. So that's what's going on. Here's a little closer view. Wait a minute. So 211 angstroms there is a fantastic wavelength, especially when coronal holes are the thing. So there they are. That is the sort of feature that is causing the high-speed wind. And let's move to sunspots. Sunspots. We've had a tiny raising of sunspot number here. We're at sunspot number 70 at the moment. 70 sunspots, and we should see an uptick going into tomorrow's video. So if it does go down, it'll only be down a little bit as we have new regions rising. But anyway, let's get to Solon.info. Now, if you want to look up this data yourself, Solon.info/solar. There's all kinds of important data there about the solar cycles and so forth, comparisons. So let's just take a brief look here at one of the things. And now keep in mind, this is over 3 weeks old. But we're going to show this anyway, just to show what's going on right now. So right now we have a lot of solar field cancellation happening. Now, again, keep in mind, this is actually over 3 weeks old. Last update was January 4th, January 3rd. So the green line here represents the north polar field reversal. You can see it crosses the line, but it has recrossed the line here. Okay, so it's actually unreversed again. You can see this blue line, that is the polar field north. It has actually crossed the zero line again and gone back in the northern territory. Now the red line, not sure what that's doing at that point. I believe the red line has reversed in earnest and not turned back yet. So this is an extension of the solar maximum. I mean, we're not at solar maximum yet. Keep in mind, this is a thing that can only be retroactively really understood because it is the sunspot number max represented by this pink line. So we are unlikely to be there yet, as we've said repeatedly on the channel. And as far as weak solar cycles go, well, solar cycle 25 is a significantly stronger cycle than solar cycle 24. So, for everybody who is very concerned that we'd see weaker and weaker solar cycles, well, that's not what's happening. So you look at that olive-colored line there, much stronger solar cycle than solar cycle 24, and we're not even at solar maximum yet. That's not likely to happen until something like, I'll say, October of 2024. So we could see it even start to flirt with the levels of solar cycle 23. So anyway, there you go. There are the comparisons of solar cycle 25 through solar cycle 21. Anyway, moving on to more sunspot stuff. Here is the synoptic map. And as you can see here, we've got a solar flare risk on the western limb. So these are likely to produce large flares just because of their proximity, but also a new flare player is rising right up here. So that looks like a complex sunspot. It's already producing some brightening there. So we've got now 3 locations: the northeast, the northwest, and the southwest. So large flares possible here, and possible here. Those are the facts. Hopefully they didn't offend you too much. And there are the flare monitor and solar flare scoreboard. So yeah, it looks like we've got like 2 or 3 new sunspots that are likely to get named in the east. And there was a moment there with quite a high likelihood of solar flares, large flares. So sunspot 3559. Anyway, the western limb is the most likely place for a large flare, but the northeast is emerging as a solar flare player. So here is the SDO continuum along with 171 angstroms to highlight the active regions there. And now here we've got coronal holes. Okay, so This is a prime example of the difference between, and this shows actually some depth here. So this is really good. So let's check this out. So for example, right here, strong magnetic fields in the photosphere, strong magnetic fields in the photosphere. Here, strong magnetic fields in the corona. Strong magnetic fields in the corona. These are separate features, folks. The photosphere is 2 layers below the corona. The photosphere is almost like the surface of the sun, the area where sunspots occur. The polar fields are part of the sun's atmosphere. In between there, you have a layer called the chromosphere, which is the transitional zone. That's a very thin layer. And anyway, just a quick note about that. To sort of get back to what I said earlier, I would explain how the fields are. Well, the photosphere fields are where sunspots are. The polar fields are the solar atmosphere or corona. Anyway, here's just SDO continuum by itself. And here's me evacuating the screen. So yeah, at least 2 new sunspot groups likely to be named in the east by tomorrow. Besides that, not a lot going on. Looks like one group did spontaneously form down here, though. So, but besides that, pretty quiet. Yeah, there's a new group there as well. So, what do we have? What do we have named? Yeah, we'll have like 3 new sunspot groups tomorrow. So despite these setting groups, we may see a small rise in sunspot number. Energetic particles and so on are next. And yeah, proton flux, no spikes. But now that we have a flare risk and we have a coronal hole high-speed stream, the likelihood of proton flux goes way up. So don't be surprised to see a proton event. Much more likely with a coronal hole wind stream currently impacting the Earth's magnetosphere. Goes X-ray flux here. Yeah, just mild upticks there, and I believe they came from that southwestern limb, exactly where we forecasted yesterday as the highest solar flare risk. Let's take a look at that. Yeah, let's take a look at that, shall we? Here's 94 plus 131 angstroms. And let's zoom in a little bit closer on some areas. First, the same zoom, but the northern hemisphere. There's the southern hemisphere. And let's take a close look at these western sunspots. So this is the second most active sunspot, I think, if it's not that one in the northeast. I think this is the most active sunspot. It's our TMAS for the day, the most active sunspot. So just follow the hashtag TMAS on YouTube, and you'll see the most active sunspot. Are we hashtagging it? I think we're hashtagging it. Maybe you could just do a search for TMAS. I don't know. It's not a very popular abbreviation. The most active sunspot. There's an extreme close-up of it. Yep, that's the one. That's where those C flares came from. It'll still be capable of producing large solar flares for at least another 36 hours, maybe? Over a full day, because there's still one active region there that hasn't set yet. Anyway, once again, there's the equatorial zoom to give you a holistic picture. Eyes on that upper left. And the entire right side, that whole limb. The hottest spots for solar flares. And we'll get to CMEs here in a moment. First, a star chart. So star chart's next. Don't chart. Just check out the star chart. And yes, Pluto being in conjunction with Earth does absolutely nothing except to your perception. So when we show the next imagery, anyway, this is what's going on overhead right now in Lehigh Valley. That imagery right there, if you're like concerned of where planets are in relation to Earth and stuff, it's not science. It's not science, dudes. It does not matter when Pluto is in conjunction with Earth and stuff. It's It's just icky. It's just icky. Icky nonsense. Anyway, here's a solar system forecast. Hopefully you haven't been falling victim to icky nonsense on YouTube. That's where things will be on February 4th. We will have a crescent waning moon by that day. And let's move on to the astronomy photo of the day, which we'll have to make full size. Oh my God, what has happened here? Dear God. Anybody want to guess what that is? Look at this odd formation right here. This is why I stayed zoomed. This area right here. Look at that. What's up with that? Why does it have that structure? Is that like because of the crystalline structure of whatever's making up this ice? Yeah, this is a very high-res image right now. And if you want to guess what it is, take a guess while we take a little tour of this object. I'll show enough that there is some chance you may be able to guess what it is. So let us know in the comments. I'll give you this much of a hint. It is a spherically shaped body within the solar system. This is not an exoplanet. Is that enough of a hint? I don't know, but that's about all I'm going to give you besides this imagery. Yeah, we're doing a very close-up little run-through here. So you've got ice, you've got craters, you've got mountains, and you've got some variable areas there that have ice and rock, it looks like. And there it looks like some regular old everyday rock. So I don't know what object you think that is. But if you want to find out what it is, maybe head to NASA, maybe head to apod.nasa.gov, and whatever you do, don't attempt to sneak up on a dragon in its own lair. You will fail to surprise said dragon. It will know that you are coming, and it will have let you in, which might be to your detriment if you think of it. Anyway, have you guessed what that is? I knew what it was as soon as I saw it because I'm familiar with this object. It's Pluto. apod.nasa.gov is where to find the imagery if you want like Pluto on your desktop or something. Anyway, CMEs are next. Some of those might look like Halo CMEs. Some of those might have you ready to hide in a bunker. Should you really hide in a bunker, though? I mean, even if they were earthly directed, would they be bunker-worthy CMEs, folks? Let us know what you think in the comments. And if you're viewing the video from a bunker right now, make sure you leave us detailed directions on how to get to it, just in case there's a zombie apocalypse. Thanks in advance. So here are our coronagraphs, and we're not going to spend a lot of time on this because guess what? Those aren't earthly directed coronal mass ejections. So here are our custom coronagraphs, and we'll show you why they aren't earthly directed here in a little moment. But yeah, just some eye candy there. And damn, I must have forgotten to put the C3 in there. Let's get even closer. So a great example of some CMEs there that are not earthly directed. So you can see that they're coming from areas that are not really in the Earth strike zone of the solar disk, which is, I mean, kind of basically the way it works, folks. When you have a CME that's sort of within this area right here, it's a lot more likely to be earthly directed than if it's outside of there. And these CMEs are outside of there. So it is possible for a CME from a spot not even visible on the other side of the sun to produce a majorly Earth-directed CME. That can happen, as these things can move a lot as they exit the corona. But all things considered, those don't look earthly directed. If you disagree, make sure you let us know in your full rage mode. Make sure you comment in full rage mode. We encourage rage comments here at the Smash News Network, Least Busted Name and News. We won't mute your comments. Go ahead. If you think you've got valid criticisms of the channel, by all means, leave them. And our viewers will laugh and laugh. And then we'll say, what would you like us to do differently? And then we'll say, oh, that's a terrible idea. We're not going to do that. Anyway, moving right along, it's time to get to filaments. So let's see what's been going on at Cerro Tololo, Chile for the last 4 days. And massive filaments are what are going on. And we do have a big prominence rising up here in the northeast, I think. Look at the last images. Big prominence up there and a big prominence in the southeast as well. So more active regions, possibly sunspots, are about to rise. Anyway, filaments, we got some dense ones, and we have some dense brains that watch our channel, which doesn't mean you're stupid. That means you're smart, actually. If you're a dense person, that means it's hard to get information into your brain. If you have a dense brain, it means you have a high IQ with lots of folds in your brain. Anyway, these filaments are already named, but if you want to name the rest of them, follow the hashtag NameThatFilament on Twitter, x.com/smashomash, x.com/smashomash. And you too can name filaments after your friends, your foes, or even yourself. Before we get to bonus features, here are the latest images from the GOES 16. Again, eyes on this region up here. We'll be monitoring it, folks. You'll be perfectly safe because, quote, we'll be monitoring it. Have you heard channels on YouTube that say utter nonsense every day? Say, oh, we're going to monitor a thing, folks. You'll be perfectly safe because we're going to monitor it, okay? We're less effective than the government, but we're here to monitor things for you. Oh, you're welcome. Quote, we will try to gaslight you, and we'll monitor things. Oh, yeah, we'll keep you posted. We won't have our heads deep up our colons or anything. No. Anyway, here come bonus features, starting out with satellite charging hazards. And we have some of the surface charging variety over places like Western Africa, Saudi Arabia, our ally, America's ally, Saudi Arabia. And some significant surface charging there. Could cause some minor communications breakdowns. You might see some glitchiness on your weather satellites, for example. GOES electron flux here at very low levels. No surprise there. However, now we can actually forecast an increase. So let's see what NOAA has to say before we do that. The 1 year graph. There you go. The last year of relativistic electrons. And NOAA's forecasting flat levels here. But when the coronal hole high-speed stream ends, we'll see an uptick in the electron flux. So that's something. And since the coronal hole high-speed stream wasn't really forecasted, you can expect that second green box. In other words, here's NOAA's forecast. And here's my forecast. It's going to be way up there. Yeah. Oh, my God. Way up there. It'll be a little spike in the electron flux, and maybe that'll be bunker worthy. So let us know if a spike in the electron flux is going to send you to the bunker, because I think bunker life is the only life. I think MREs are the only nutritious food to eat. There's totally no preservatives in those. They're really good for you. Let's take a look at the vibrational frequency of the F layer, the bridge between Earth and space. Congratulations, you've bought 25 years worth of food. You better start eating it because it's, going to go bad in like 20 years and you'll have to eat all of that emergency food at some point, or it'll be featured on a YouTube channel that eats expired food. Let us know if you watch those. Shout out to Ashens. Yeah, Ashens. He's fantastic. And also shout out to Steve 1989 at MRE, what is it? MREinfo.com or something. Steve 1989 at MREinfo.com. That guy's fantastic. He's a military ration specialist. Anyway, here's the anomalygram for the ionosphere. And you're seeing a lot more red on here because of the incoming coronal hole high-speed stream. So just awesome there. Something going on. And a little bit of space weather. It's about time. Plasma miser. Yeah, the sun's been being a plasma miser, folks. Are you gonna tolerate that? If you have angry comments for the sun, leave them in our comments section as well, as many viewers are convinced that the sun watches our videos. Next, the global ionospheric nowcast. Yeah, if you think the sun is conscious, make sure you leave comments. Maybe it'll put signals in the next video to answer your comments. What do you think? That's not reckless. What's reckless about that? Anyway, that's the WHAM, the whole atmosphere model, the global ionospheric nowcast. Don't like it? Don't watch it. Next, the latest high-res imagery. There is the magnetogram, and there's that, and that's what's going on. And let's get to meteorology because it's Sunday night, and this video's premiered slightly early, so you're welcome. And by the way, let's look at the stormiest seas in the world. There you go. There are the world's stormiest seas, and it's not that bad, folks. Only 32-foot waves out there. I mean, many of Vikings would be happy to be on a longboat in that weather and the frigid water off the coast of Norway. I don't think I would like that much, although I am definitely at home on stormy, foggy seas. So, I don't know. Anyway, like I said, those are the world's stormiest seas. There are some other stormy spots, kind of, like these seas aren't quite as high, you see. Only 27-foot waves out there. And as far as the Southern Ocean, there is a spot down here south of Tasmania that's looking a little bit promising. But off the coast of Norway is the world's stormiest waters. So there you go. The North Sea, folks. Anyway, here comes regular meteorology stuff as we bring your weather from space down to Earth. Oh, and let's check it out. There you go. There's your auroral ova. Oh, not your auroral ova. I'm sorry. Your auroral zygote? No, it's not an auroral zygote. Your auroral fallopian tube? Wait, it's not that either. Your auroral vas deferens? It's not that. Your auroral oval. That's right. Not an auroral ovum. Ova? All right, forget that. Here are surface winds of the east. Here are jet streams of the east. Jet streams of the central world. Your auroral umathermon? It's not that. Surface winds of the central world. Surface winds of the west. And the jet streams. Jet stream convergence happening over the Gulf states. Oh my God, a jet stream convergence. No! Get in your bunkers quick! Cover yourself in mud! Or something. Here come clouds and fog for the Americas. Tell us in the comments what you think is bunker worthy for the day. Ooh, what are you spooked of? Are you spooked of facts? Oh, noes, watch out, facts. Here's a low pressure zone. And we showed it over as it made its way from Missouri toward Indiana, and now it's kind of stagnating. It's sort of hanging out there over Ohio, overstaying its welcome. As you can see, some wind shear there affecting it, looking like a blocking mechanism from the north. Anyway, let's check snow cover. Pretty decent amount of snow right now for the U.S. And even some snow in Mexico currently. Check it out, folks. That is snow cover for, well, the planet. Next, our weather.gov map. And there are some alerts. What's that olive-colored crap? Let me press refresh. I think there's something messed up. High wind watch. Oh, my God. There's a high wind watch. Dear God. Anyway, some winter storm warnings in there as well. Let's take a look at some forecasts, starting with the temperature anomaly. The GFS 72-hour model for the temperature anomaly. It's in degrees Celsius, otherwise known as disease centigrade. You've been diagnosed with centigrade, folks, and it's terminal. That's the data from my terminal. Check out the warm weather coming to the central U.S. there. The Great Plains are going to be at 16 degrees above normal. And it's been a warm winter, folks. Look at how warm that is. That's the last few days of January. You know, mid-January through mid-February is the coldest part of the entire year. That's pretty warm. Does that look warm to you? If that's controversial, you might be an utter moron. Anyway, here's our pressure and precipitation forecast for the same model. We're only showing the GFS 72-hour model. We show it every day on the channel because it's accurate. Not because it's accurate. Heavy precip coming to California once again as wave after wave of bonsai pipeline water makes its way from the Pacific Beltway, the hydrologic beltway, carried by the jet stream straight to the Pacific Northwest. Dag! So here's accumulated precipitation, and this is only showing the beginning portion of another heavy moisture influx for especially Northern California. But, well, there it is. I mean, it looks like it's going to move slightly to the south as it makes landfall there. Another atmospheric river about to show up at the shores of the left coast. Accumulated positive snow depth change in inches is next, and that's making me happy as we've got more snow forecasted for Lehigh Valley, Pennsylvania. Oh yeah, my windshield wipers are already up, baby. Woo! More snow, bring it on. And let's get to lightning. Lightning. First, a real old lightning map. That's like 10 hours of lightning. Let's look at a real-time lightning map from lightningmaps.org. Next time you hear thunder, well, you're probably on a boat because there's no terrestrial strikes in the U.S., so what do we got? We got some lightning from under? No lightning from under. Ah, man. Eastern Mediterranean's got some lightning. Am I allowed to even show this part of the map, or is this too controversial? Is somebody going to protest the channel if I show this lightning? All right. Let's close this thing out with Doppler radar, clouds and fog, and water vapor. So there's the precip picture for the full 50. There's the precip picture for the lower 48. Here's clouds and fog. Again, that low just kind of hanging out there around the Ohio, Virginia, Kentucky tri-border. There is water vapor, and you can see that extended region there. A bunch of water kind of constrained by this dry mass of air, which is a relative high, acting like a blocking feature. This is a relative low. It's not a very powerful low, but being surrounded by that high makes it a relative low, which is enough to affect what's going on in the eastern U.S. This is your recap. When your Doppler's unclear, if you understand atmospheric physics, the water vapor map will deliver you from ignorance. Because the Doppler often makes little sense without understanding things like pressure variations. Anyway, I'm going to alter my pressure by climbing back down into the bunker. And in the meantime, may that solar wind be at your back.